Yeah, hello everyone. I can maybe share my screen. We have a few hackathons running at the moment. So I just want everyone to know that there is first hackathon is Polygon Built It Hackathon. It started June 15 and it runs until July 25. You can still participate. They have prizes about 500,000 prize pool. There are workshops, there are different talks, different sponsors, and we with Fluence we're sponsoring as well. So just check this out. Then next one is Sustainable Blockchain Hackathons. That started June 23rd and will be running until July 18. Sustainable Blockchain Hackathon runs through Gitcoin platform if you used it before. If you haven't, just sign in with your GitHub and your wallet, and then you can participate, join the hackathon, and see the bounties in the Gitcoin. They also have the program of the hackathon. You can watch different workshops and talks. And here are the prizes. And then the next hackathon we are participating, that's Hackafest. That starts tomorrow and until the end of July. That's the page here. So tomorrow is the opening of the hackathon. And we just had our workshop, Bernard. Okay, sorry, it's just freezing. And these are our bounties. We will publish all the links somewhere in the channels in Discord.
Okay, so lots going on. Anybody interested in hacking, exploring Fluence, sign up. Lots of them coming. Great prizes. And I think next we have updates from the tech team. I don't know, Mike, do you want to kick it off?
Yep, I could share an update from the machine teams. So I want to share like our progress. So internally, our team called machine department, and internally, and like last month, we established a process in our Influence Labs that allows like everyone to share progress for last months and for every department in our Influence Labs. So this presentation from our internal all hands meeting, and regarding the result of the last month, so like the June starts for us with releasing the Marine book. So we presented it on a previous call, so you could find it by this link. So Marine book includes like almost everything that you should know about Marine. Architecture, SDK, tool reference, and so on. Then, after releasing Marine book, we rethink the architecture of Marine itself, and we came with the following idea, with the following picture that represent architecture of Marine. So here you could see several rectangles. So rectangles on the top layer represent that like top level API of Marine. So they were written and they divided into Rust and JavaScript. They have like JavaScript and Rust side. They have similar API, but like intended for different target language. And the middle layer that consists of one rectangle called core, it represents the same code that share between these two targets. And like for Rust, it compiles to Rust directly, and for JavaScript, it compiles to WebAssembly. And it's one of the features of Marine that we have core as a single source project, single source crate that is both for Rust and for JavaScript. And on the bottom, we have blue rectangles. They represent the WebAssembly runtimes that we use. Currently, it's Wasmer for Rust and some like. It really doesn't matter for JavaScript. We could run on every runtime on Turbofan or SpiderMonkey and etc. And we realize that such a scheme allows us to serve to fit different purposes, and we factor a bit Marine layer separation just to prevent abstraction leakage between these layers. We remove several entities from several things from the top layer called Marine to the layer that uses actually Marine. It's called Fluence App Service. So the things includes some internal things like call parameters, configuration files, and stuff like that. So the scheme was partially implemented in code. We have still some stuff to do. So I think we will continue doing that next month. But it's nature of separation, and now we could call Marine as runtime without any reference to Fluence. And also Marine could be used outside of Fluence as a runtime itself. And also as so I mean that you could use Marine embedding in your Rust project or in your JavaScript project as a general purpose runtime that allows you to simultaneously load several modules, combine them together with a shared message linking scheme, and use it in several manners. Next, so in the middle of the previous month, we have so-called summit. It takes place in St. Petersburg and took a week. The summit was some form of global team synchronization. So on the summit, we decided what to do next with Marine runtime, how we could approach last changes in the WebAssembly proposals. Also, we stabilized roadmaps for Marine and AcuVM. So Marine and AcuVM is two main projects in the machine department in Fluence Labs. And also we discussed several more or less all stuff like testing and deploying a framework for AcuVM, improvements in Marine CLI, developer experience, service configs, and more that I didn't go to the slide. After the summit, so we decided to focus on stability and performance. We want to make this performance and stability as a first-class citizen in our team. So we want to focus on all next iterations. And during this work on stability and performance, we found and fixed the problem with the memory leakage. So with help of Valery, and Valery will present details later on the community call. Then we also dramatically improved the AcuVM performance. So the fix was rather short, but it will allow AcuVM to work much more performance than it was before. And we have several about 5 more optimization in pipeline that will also improve performance in about 1 or 2 orders. So it will be in the next month, I think. Also, as I said, that we want to focus on performance, and that's why we wrote the first version of Performance Analyzer. So this Performance Analyzer allows you to see what's going on internally in AcuVM. What's triggers this memory usage, or this or some function takes so long time to execute, and so on and so on. So we integrate it to our pipeline, and all next changes in AcuVM, they will be analyzed with this performance analyzer. So here I want to credit to Ivan doing that. So it's really good job. Thank you, Ivan. And finally, we implemented a mechanism for logging anomaly data. So by anomaly data, we call data that executes quite long, more than, for example, 20 milliseconds, or, for example, it triggers a lot of memory consumption inside AcuVM. So we implemented this mechanism. It's already deployed in Krasnodar. And we have a way to find anomaly data from real network and analyze it with our performance analyzer. So it's our main results of machines department, and later Valery will present some internals about this bug that was fixed. It's really interesting. So I think that's all for machines.
Very cool. Anybody have any questions for Mike? All right. right, I have some, but I'll save them. Valery, I think you're right next in line.
One more thing before we proceed, on the event side, I think what we forgot to announce is, like besides online hackathons up and running, we have 2 offline things going on next weeks. One is the IPFest conference with Protocol Labs in Iceland, happening like next Monday. All week we're gonna be there. And then ESTP and like this Ethereum week in Paris. A lot of people gonna be there. We're also sponsoring hackathon there and gonna host some more events, but I think we don't yet have the exact schedule. So just whoever gonna be in Paris, happy to meet. Please join our meetups. We'll happy to see you in person. Yeah, sorry, Valery. That's it.
Okay, that's fine. So as Mike said, we found a memory leak in Marine, but it was actually embedded in WebAssembly files. And I need to tell some prerequisites for you so you can understand what happened and so on. First, in the last years, like 1 or 2 years, WebAssembly WASI group was developing a new execution models, common model and reactor model. It's their models of execution of use case or execution of WebAssembly model. So command is like a usual binary that usually executable on your computer. It has a single entry point. You execute it, then you drop, and it's pass the state control back to the caller, and then all resources are freed. The memory state is no longer valid. It must be thrown to the trash and reused. So, and the reactor model is something new. It compared to shared libraries. And in case of WebAssembly, it looks like that. It's WebAssembly that has an export function for initialization and has many export functions that can be called after the initialization function call, and they will reuse the state, reuse the memory, the globals, and so on. And the command module can also have many export functions, but there is only one can be called on one instance. Like you instantiate a model, call one arbitrary function once, and then you can't use this WebAssembly instance. Okay. And before these execution models, all modules were like commands, but there were no documentation or guarantees or rules or something that say that you can call an export function twice or 2 export functions on one module. Okay. And what we do in France, we create marine services from WASIs, and they are reactors by the definition, by the use case. They are compiled as commands, but we call many export function many times, and we have some kind of initialization functions on each one, and some kind of initialization function on each model. So they like reactors, but we compile them as commands because there were no other way to compile WASI. But there was a future problem that someone can start distinguishing commands and reactors and start using the differences between them. And that happened. Rust C 1.56 switched to LLVM 13, which added support for command reactor execution models and started emitting the code for WebAssembly different. By default, it's command, and in that mode, it wraps every export function with constructors and destructors calls that, like wasm call ctors initializes the state, and wasm call gtors deinitializes the state by design. It's good for commands. You need in every command and in every export function an initialization and the initialization. In our case, wasm call stores initialized WASI libc and initialized pre-opened files. Initialization of WASI libc includes memory allocation, copying the environment variables, and it allocates the memory and stores it somewhere in the WASM. And this memory, like expected to be freed in the WASM call editors, but WASM call editors does nothing, literally nothing. And it may call also static constructors, static destructors from other languages like C++, but in Rust it doesn't. There are no static constructors or static destructors. So each export function, if we call several export functions, then we have the initialization function called several times, and nothing frees its resources. So it's a memory leak by definition. And moreover, our IT interface types implementation uses several export functions to work, to pass values to the WASM and outside of the WASM, allocate, release objects, and result related, and they all also wrapped with ctors, detors calls. And that's a huge memory leak and a huge performance degradation, because if you send a vector of 1,000 strings, you will have WASM call stores called more than 1,000 times during one call, and all of them will leak some memory. So it's super bad, and that's super hard to find. You have memory leak, but everything inside your Rust code is fine. But there are two ways to mitigate it. First is to add explicit WASM call stores call in function named start or initialize. So LLVM will detect it and will not wrap functions with stars and stars calls. Just will do as it did before, or pass the huge feature, or pass the flag to the LVM through Rust that we need to compile a reactor, not a command. But it works only in night Rust, and we don't want night Rust. And we researched what the community says about it, and we found that people have the same issue on their side because of the problem. And people who work on these changes just think that they misdesigned it, and there is no workaround except that I mentioned. So what's next? We will use an explicit constructor call that I described it, and the one problem is that you'll need to change the SDK when the support of the reactor's commands will be in stable Rust. But it will require nothing from users, only changing the SDK version. because everything will be inside of SDK. Or we could use the option from nightly, but we decided not to do it because we don't want to switch to nightly, and still we may have to change it when our interfaces will be stabilized. So our plan, we will use the explicit constructors approach. We will bump minor SDK version, bump minor Marine version. We'll return an error when loading a module to the new Marine that is compiled with the old SDK before the fix. And we will release updates for everything, for SDK, Marine, Node, REPL, examples, documentation. We will announce it everywhere, and we will do it in the second half of July, because we have now many ongoing hackathons, and we want our systems stable at the time of the IPFS summit. We don't want that people will encounter some errors, wouldn't be able to load modules to the network, and so on. We just fixed our infrastructure services like registry, graph, and Aqua IPFS. We just added workaround to each module. It is possible because we only need to import a function and call it. So that's a story of one disaster we found. And if you are using WASM, you may have to check your WASMs too, because you may be affected by this problem, and maybe you will need to work around that. So thank you. Ask me your questions you want, or everything.
Right, thanks, Valery. It was great. Anybody questions for Valery? Memory leaks and fixes. Okay, then let's move along. We have Folix, aka Alexei, with a whole slew of updates on measurements, metrics, and system improvements.
Can you hear me?
Yeah.
Great. Well, okay. So, yeah, I don't have any fancy presentations. This was very awesome, by the way. Yeah, and I guess I will start with the performance, just to continue what guys were talking about. What we've been doing on the network side. What I will be talking about, like we have several teams and stuff inside our Fluence development teams, and one of them is the network team that I will be reporting on right now. And what we do, we work on like network, Rust peer, DevOps stuff, infrastructure stuff, all that, all the surroundings, built-in services, just services, everything like that. So when guys from machines team deliver on performance, it's our job to integrate it and run it and deploy, and so everyone can experience it. That's exactly what we did, like integrated and deployed fixes from machines team. So huge performance improvements. Now different Aqua scripts, they just as fast as light, because everything is improved, both services and Aqua VM. So particles interpreted fast, service calls are fast, and everything just flies. That's awesome. Also, we started to dig deeper on performance. We integrated anomaly detection for particles. So if some particles are like executing too slow, previously too slow was around 20 to 60 seconds, and now too slow is around 500 milliseconds. So you can already feel the difference in performance. Yeah. So now we're collecting those particles, save them to disk, and that allows guys on machines team to like take that data and experiment and debug and profile locally. Previously, it was like only line in logs that said, hey, this was slow, and that was it. Now we can actually address these issues. That's awesome. Yeah, so we're still investigating some timeouts on node starts. That happens because some of the services failed to be deployed, but that doesn't actually affect anyone who doesn't host a lot of nodes like we do, so that's great. We had a lot of work invested in metrics last several months, and we delivered a lot in that area. For example, I can show you some logs right now. Let me close food delivery. Yeah, so what we've been working on, Maria was working on service metrics, and she implemented aggregated service metrics that are stored in Prometheus, and they're collected, and now we can see how many services each node has, how many services we have in total on the network. For example, we can switch here and just to stage, and we will see different numbers, right? So we can see that on stage we have only this much services, and every stage node has this much services, and it all looks a little bit better because less data. Yeah, so we can understand what's happening on the network services wise. We can see how they use memory. We can see that total use memory grows constantly. That's because we don't have the allocation in we don't free memory in WebAssembly services. So every time a lot of memory used, it just stop at that point. Yeah, and we can see here in this graph, we can see that currently most of the services have only one module. Roughly 1/5 of them has 2 modules. Just a little really small number has 3 modules, and there are no services with 5 modules in it. We can see it, and once we will have some more complex services, this numbers will start to grow as well. Yeah, also we can see how many free memory services have in average. It's a histogram, so yeah. That's all really awesome and gave us a lot of insights. Also, we have what we have also. Also, we have, I already presented several months ago, but now we kind of moved to a new infrastructure and it's all green. I will just scroll real fast. So this is node metrics like Rust peer metrics. They show the overall health of the network, and we can see that everything from the last 6 hours was fine. If we switch to 24 hours, we will see that some nodes on testnet died a few times because they have too much services, for example, and they just ran out of memory. And we can see how many particles arrived, how many particles are arriving per second, stuff like that. We can see what the current kind of bandwidth on the network we have, the average size of the particle. We can see that most of the particles here are between 1 kilobyte and 10 kilobytes, and just some of them are more than 1 megabyte. Yeah, stuff like that. We can also see the interpretation time. Previously, it was in here, around sometimes interpretation time took up to 15 or even minutes, and right now everything is below 1 second. So that's an awesome improvement. I guess we still have some, for example, here we have some particles that have been interpreted in more than 15 seconds. That's why we have anomaly detection, because sometimes it still happens. Yeah, stuff like that. And what we actually have a plan to pretty exciting thing to open this dashboard, not only for viewing, but also give a way for people who host Rust peers to send their metrics to us, say, hey, come to us and grab our metrics. And in that case, those hosters, they will be able to see themselves in this dashboard. There will be more ends here, not just our, but other people's too. And they will be able to see them on public network and with all those awesome metrics. I think that will be great. Another thing that we have, and I'm really excited because it's a really useful thing, we have finally implemented log collection. I think read that in For example, if I want to see the interpretation logs on Krasnodar, I can see, I can just write interpreted in, and I will see which particle took how many seconds, and just I can see just all the logs. For example, I want to take a look how this particle was like traveling through the network. I can just enter its ID, and I will see that it started to run. There were some failures. Some nodes couldn't reach other nodes because sometimes we have nodes run by other people and they don't have like ports open, stuff like that. So this particles, they often span the whole network, so they can kind of span nodes we don't control, and they can be unreachable. That's completely fine. And we can see that once it gets to one var nodes and starts executing, we can see like it was executed traveling between the nodes and stuff like that. That's pretty awesome for debugging. That will speed up our development quite a bit. So that's awesome. What else? Yeah, and we got our team got bigger. We got Anatoly in DevOps position, in infrastructure ops position, to name it correctly. We finally moved to AWS for continuous integration because we need like powerful machines to build Rust binaries, publish Docker containers. I think at some point we will move our continuous integration to Fluence, but while we don't have that, we're using GitHub Actions. So, and the runners are now on AWS, and builds now take like 5 minutes instead of 30. That's awesome too. And overall, we're moving to zero trust infrastructure. Want to have some expertise in it and apply it, gather it, like learn how industry works in that sense, and apply that knowledge to design influence. Yeah, that would be great. Also, we had quite a bit of different developer experience updates. Like there were problems with creating services where you got an error and you couldn't like decipher it. You couldn't understand what it really tells you. Now you could. Anyone can, because it just tells what's wrong. That's awesome as well. Also, we had a lot of work done on built-in services like registry, trust graph, and stuff like that. They are now have all the fixes from machines team, so the performance rise up quite a bit, and they work real fast and they work without bugs. We started to cover them with Aqua tests. Before it was only Rust tests, but now it's kind of end-to-end integration tests that could span several instances of service, so we can like actually cover with tests the distributed properties of the services we develop for the Fluence network. Yeah, I guess that's it for me.
All right, great. That was a great update. Obviously, lots of improvements on that end. Going to benefit everybody. And I don't know, I think that's about it. Anybody else?
Service on your local computer, you would have to write the whole JavaScript project with packages on and all that stuff. You have to it was rather complex. And right now you can just write a simple JavaScript file that has export function plugins that returns an object where with just functions. Like, for example, I want to define a service called IPFS client that has function upload that would go to remote IPFS node and upload some file to it. And I want to use that function from Aqua, like this. Like, for example, I want to have this kind of service in Aqua. And previously, I would have to write index.js or index.ts and manage dependencies and all that stuff. And right now, things has changed. All you have to do is just have an MJS file with your service definition, and it should be returned from plugins function. And you can have a service that you can call in Aqua. And that's pretty awesome. I think I wouldn't wouldn't go into too much details, anyone who's using Aqua should be excited. If you don't know what I'm talking about, then you should read Aqua book and come to our chats and ask, and I will teach you how to use the plugins and so on. I guess that's it. That's a short description. It's really awesome feature, changing the whole experience of Aqua development. So yeah, maybe we'll have a dedicated call to it.
Okay, way to bury the lead. All right. I think, have any questions on that? No. All right. Well, then, thanks everybody for being here, and we'll see you in 4 weeks. Have a great 4 weeks. Cheers.
Cheers.
Thank you.
Bye.
Bye-bye. Thank you. Bye.